The dawn beyond Earth. In the summer of 1977, two identical spacecraft lifted off from Cape Canaveral carrying something unprecedented. A golden record containing sounds and images from Earth. A message in a bottle cast into the cosmic ocean. Today, both Voyager probes have crossed into interstellar space, becoming humanity's first ambassadors beyond our solar system, traveling at over 38,000 miles per hour into the infinite dark. Yet at this speed, it would take them 73,000 years to reach the nearest star. This single fact reveals the staggering truth we must confront. The universe is so incomprehensibly vast that even our fastest machines crawl like insects across distances that mock our ambitions. But here's what should keep you awake at night. Scientists now believe that within the next 2-3 centuries, if we survive that long, humanity will take its first genuine steps toward becoming an interstellar civilization, not in science fiction, not in distant millennia, but possibly within the lifetimes of people who will be born in this century. The question isn't whether we'll attempt it. The question is whether we'll succeed before we destroy ourselves, and what we'll become in the process. Because the moment we leave our solar system permanently, we stop being human as we understand the world today. We become something else entirely. Ask yourself this: if you could guarantee humanity as survival by sending your children on a one-way journey to another star, knowing they'd never return and you'd never hear from them again, would you do it? This isn't a hypothetical question. This is the decision we may face within your lifetime. The concept of interstellar civilization represents one of the most profound transitions imaginable. The moment a species confined to a single star system spreads across multiple star systems, establishing permanent presence around different suns. It's the difference between being terrestrial and becoming truly cosmic, between having one basket for all our eggs and distributing ourselves across the galaxy. But to understand why this matters, and why scientists from Carl Sagan to Stephen Hawking have insisted it is not optional but necessary, we must first grasp what we're trying to escape and what we're moving toward. Earth has existed for 4.5 billion years. Modern humans have been here for roughly 300,000 years, and we've had industrial civilization for only about 250 years. In cosmic terms, we're newborns, and newborns are fragile. Our planet orbits a star that will eventually expand into a red giant and consume the Earth in approximately 5 billion years. Long before that, increasing solar luminosity will boil our oceans in around 1 billion years. But these distant threats pale compared to immediate dangers: asteroid impacts that have caused mass extinctions before and will again, supervolcanic eruptions that could trigger global winters, nuclear war, engineered pandemics, artificial intelligence gone wrong, climate collapse, or any number of self-inflicted catastrophes that could reduce our population to zero within decades. Stephen Hawking stated in 2016 that he believed humanity had about 100 to 1,000 years to establish presence beyond Earth before something catastrophic happens. Elon Musk has echoed this urgency, arguing that becoming multiplanetary isn't luxury but necessity. The logic is brutally simple. Single planet species is one cosmic accident away from extinction. But surviving isn't the only reason. There's something deeper, something written into human nature: the drive to explore, to see what lies beyond the horizon. Every culture that ever existed produced explorers who walked toward the unknown despite knowing many wouldn't return. The Polynesians crossed vast Pacific expanses in wooden canoes without knowing if land existed. European explorers sailed toward the edge of their maps where dragons were drawn. This drive isn't irrational, it's evolutionary. Curiosity and exploration allowed our ancestors to spread across Earth, finding new resources, escaping local disasters, surviving when other human species like the Neanderthals remained confined to smaller ranges and eventually vanished. We are descendants of the ones who left, and that restlessness lives in us still. Now imagine the challenge. The nearest star system, Alpha Centauri, lies 4.37 light years away, 25 trillion miles. With current technology, reaching it would take tens of thousands of years. This isn't like colonizing a new continent where ships could sail for months and establish contact. This is a gulf so vast that communication alone becomes almost meaningless. A radio signal traveling at light speed takes for years to reach Alpha Centauri, and another 4 years for any reply. If you send a message at age 20, you'd be 28 when you got a response, assuming anyone was there to respond. And remember, this is the nearest star. Most stars are hundreds or thousands of light years away. The scale is so overwhelming that it breaks human intuition. This is where scientists and visionaries diverge into different schools of thought about how interstellar civilization might actually emerge. Ask yourself, would you volunteer for a journey that takes multiple generations? Knowing your grandchildren's grandchildren might reach the destination, but you never would. The first approach is the generation ship concept, perhaps the most haunting vision in all of interstellar theory. Imagine a massive spacecraft, essentially a self-contained world, launched toward a distant star with thousands of people aboard. These pioneers know they'll live and die aboard this vessel. So will their children and their children's children. The ship becomes their entire universe, a hollow metal world sailing through the void for centuries. Physicist Freeman Dyson calculated that with nuclear pulse propulsion essentially detonating nuclear bombs behind a spacecraft to push it forward, we could build generation ships with current technology that could reach nearby stars in 1,000 years. More advanced designs using fusion propulsion might reduce the journey to a few centuries. But the challenges transcend engineering. Inside the ship, entire civilizations would rise and fall. People would be born, live, and die having never breathed unfiltered air or felt sunlight on their skin or seen a horizon that was curved metal. What happens to human psychology across such time scales? How do you prevent cultural decay? Maintain mission focus across 20 or 30 generations? What if the descendants decide they don't want to complete the mission, that their content drifting through space forever? Anthropologist Cameron Smith has studied this, estimating that a minimum population of 14,000 people would be needed to maintain genetic diversity and prevent inbreeding collapse over such voyages. That's not a spacecraft, that's a flying city, requiring agriculture, manufacturing, governance, education, all sustaining themselves in isolation. Some theorists, like physicist Robert Zubrin, have proposed embryo colonization as an alternative. Instead of sending living adults, you send frozen embryos along with artificial wombs and sophisticated AI to raise the children. Upon arrival, this dramatically reduces mass and life support requirements, but it raises profound ethical questions. Is it moral to create children who will be raised by machines on an alien world with no adult humans to guide them? What kind of society emerges from such origins? Then there's the cryogenic approach, freezing colonists for the journey and reviving them upon arrival. The challenge is that we currently cannot successfully freeze and revive a human being without fatal ice crystal damage to cells. But suppose we solve this in the next century. Suppose medical technology advances to the point where suspended animation becomes possible. Then you could have crews that experience the journey as a dreamless sleep, waking up at their destination as if no time had passed. Physiologist Mark Roth has done groundbreaking work putting mice and other animals into suspended animation states using hydrogen sulfide, reducing their metabolic rates to almost nothing. If this scales to humans, it transforms the equation entirely. The most radical approach involves digital consciousness transfer, what some call mind uploading. Futurist Rick Kurzweil and philosopher Nick Bostrom have explored the idea that if consciousness is fundamentally information processing and there is substantial neuroscience suggesting it is, then theoretically you could scan and digitize a human mind, transmit it as data traveling at light speed, and reconstruct it in a synthetic body at the destination. This would mean the journey to Alpha Centauri takes 4 years regardless of the traveler's subjective experience. You fall asleep on Earth, wake up in a robotic or biological substrate around another star. But here's the disturbing question nobody can answer. If your brain is scanned and copied, and the original you dies or remains on Earth, Is the copy that wakes up actually you? Is it consciousness continuation or sophisticated copying and murder? Ask yourself, would you press the button if someone offered to scan your brain and transmit you to another star, knowing your body here would be destroyed in the process? The physics of interstellar travel itself remains daunting but not impossible. The Breakthrough Starshot project, funded by billionaire Yuri Milner and backed by Stephen Hawking, before his death proposes sending tiny spacecraft just a few grams equipped with light sails that would be pushed by powerful Earth-based lasers, accelerating them to 20% the speed of light. At such velocities, a probe could reach Alpha Centauri in 20 years. The concept is sound, the engineering is feasible with substantial investment, but these would be unmanned probes carrying cameras and instruments, not people. Scaling up to human-carrying vessels that could survive impacts with interstellar dust at relativistic speeds remains an unsolved engineering challenge. At 20% light speed, colliding with a grain of sand releases energy equivalent to a hand grenade. Some scientists propose more exotic solutions. Miguel Alcubierre's theoretical warp drive would bend spacetime around a spacecraft, allowing it to effectively move faster than light without violating relativity. The spacecraft wouldn't accelerate at all, it would surf on a wave of compressed and expanded spacetime. The catch is that creating such a warp bubble would require exotic matter with negative mass energy, something that has never been observed and may not exist. Physicist Harold White at NASA has explored mathematical modifications to the Alcubierre drive that might reduce energy requirements for more than the mass of the universe to merely the mass of Jupiter. Still impossible with current technology, but theoretically conceivable. Wormholes represent another tantalizing possibility, shortcuts through spacetime, connecting distant points in the universe. If traversable wormholes exist or could be engineered, interstellar travel becomes trivial. You step through a doorway on Earth and emerge around Alpha Centauri instantly. The mathematics of general relativity allows for wormholes, but keeping them open and stable would require exotic matter. Similar to warp drives, most physicists consider them interesting mathematical curiosities, but physically unrealizable with any foreseeable technology. Yet suppose we do it. Suppose within the next centuries we launch the first generation ships or develop the first cryogenic colony vessels or crack the physics of warp drive. What happens next is what truly defines interstellar civilization. The first colonies around Alpha Centauri or Proxima Centauri or any of the potentially habitable exoplanets we've discovered would face challenges that make settling Mars look trivial. These worlds would have alien biochemistries if they have life at all, atmospheres that might be toxic, gravity that could be higher or lower than Earth's, day-night cycles that could be radically different. The colonists would need to either terraform these worlds, engineer their atmospheres, temperatures, and ecosystems to match Earth, or adapt themselves through genetic engineering or cybernetic enhancement to survive in alien environments. Astrobiologist Chris McKay has calculated that terraforming Mars alone would take centuries. With optimistic assumptions about technology, terraforming an exoplanet light years away with no possibility of resupply from Earth would require the colony to become entirely self-sufficient in advanced manufacturing, agriculture, and technology within a single generation or face extinction. There's no calling home for help with a communication delay of years or decades. This is where interstellar civilization stops being about technology and becomes about human evolution. Biologist J.B.S. Haldane once said, "The universe is not only queerer than we suppose, but queerer than we can suppose." The humans who settle other star systems will diverge from Earth origin humanity within centuries, possibly within generations. Different gravity will reshape their skeletons. Different atmospheres might require genetic modifications to their respiratory systems. Different day lengths will alter their circadian rhythms. Isolation and genetic drift will create distinct populations. Within 1,000 years, the descendants of Earth living around different stars might be genetically and culturally as different from each other as ancient human populations separated by oceans were, except more so, because intentional genetic engineering will accelerate the process beyond natural selection. Some transhumanist thinkers like Anders Sandberg propose that interstellar civilization might not involve biological humans at all, but rather post-biological intelligence, advanced AI, or uploaded minds that don't require air, water, or Earth-like conditions that can withstand radiation, that could potentially survive for geological timescales. These entities could spread through the galaxy not in ships but as information, transmitted as radio signals between stars, downloaded into whatever computational substrates exist at the destinations. This represents a different kind of interstellar civilization, not humanity spreading physically, but human origin intelligence propagating as digital consciousness. Ask yourself, if humanity spreads across the stars, but in the process we genetically engineer ourselves beyond recognition, or upload our minds into machines, or diverge into hundreds of separate species adapted to different worlds, are we still human? At what point does spreading across the galaxy mean losing the thing we were trying to preserve? The sociologist Michael Michaud has explored the political implications of interstellar civilization. The first colonies would be functionally independent from Earth. From their first day, the communication lag alone makes real-time governance impossible. These colonies would need to develop their own governments, economies, and cultures. With no enforcement mechanism possible across light years, each colony becomes a sovereign entity. Over centuries, as they lose cultural and genetic connection to Earth, why would they maintain any allegiance? We could be setting the stage for future interstellar conflicts between post-human civilizations that share a common Earth origin, but nothing else. The physicist Stephen Baxter has written extensively about this scenario: a galaxy populated by thousands of human-descended civilizations that view each other as aliens, competing for resources and habitable worlds across interstellar distances with weapons we can barely imagine. Yet there's another perspective. The philosopher Nick Bostrom argues that spreading across the stars might be the only way to preserve not just human survival, but the value of consciousness itself. Earth origin life, human thought, art, culture. Everything we value represents an extraordinary cosmological accident, complex chemistry organized into self-replicating patterns that somehow became conscious and contemplated its own existence. If this exists nowhere else in the universe, or exists rarely, then allowing it to remain confined to one fragile planet around one ordinary star seems cosmically irresponsible. By spreading across the galaxy, we increase the probability that consciousness, intelligence, and meaning persist even if individual worlds or civilizations fail. Consider the Fermi paradox, the disturbing silence. When we search for other civilizations in the universe, the galaxy is 13 billion years old. The universe contains hundreds of billions of galaxies, each with hundreds of billions of stars, many of which have planets. Where is everyone? Why haven't we detected any signs of advanced civilizations? Multiple explanations have been proposed. Maybe intelligent life is extraordinarily rare. Maybe civilizations consistently destroy themselves before achieving interstellar capability. Maybe there's a great filter ahead of us, some challenge that prevents species from spreading beyond their home worlds. Or perhaps, and this is the most unsettling theory, advanced civilizations do exist, but have very good reasons to remain. Hidden and silent, reasons we'll discover only when we venture out ourselves. What if the silence itself is a warning? What if species that broadcast their presence and spread obviously across the stars attract attention from something dangerous? This is the dark forest hypothesis proposed by science fiction writer Liu Cixin, but taken seriously by some SETI researchers. In a universe where resources are finite and intentions unknowable, revealing your location might be existentially risky. Perhaps the successful interstellar civilizations are the quiet ones, the ones that expand carefully and maintain strict protocols about electromagnetic emissions. Alternatively, maybe we're actually early. Maybe in the cosmic timeline of the universe, we're among the first intelligent species to reach the threshold of interstellar capability. The universe had to exist for billions of years to create the heavy elements necessary for rocky planets and complex chemistry. Maybe there simply haven't been many civilizations before us, and we're part of the first wave that will eventually populate the galaxy. In this scenario, how we handle the transition to interstellar civilization might set precedents that echo across the galaxy for billions of years. We could be the ancestors that future civilizations study in their history course, the species that first figured out how to do this, whose choices and mistakes and successes established the patterns all others would follow. The technological timeline for achieving genuine interstellar civilization depends on which bottlenecks we solve first. Propulsion technology is advancing ion drives, nuclear fusion, solar sails, and theoretical concepts like antimatter engines could all potentially reduce travel times from tens of thousands of years to hundreds. Life support systems are improving as we learn from the International Space Station and plan for Mars missions. The biological challenges of space adaptation might be solved through genetic engineering, which is advancing rapidly with CRISPR and other tools. Artificial intelligence is developing faster than most predicted, potentially solving the automation and decision-making challenges of multi-generational voyages. Some optimists like physicist Michio Kaku believe we could launch the first interstellar probes within 50 years and the first crewed missions within a century. Pessimists point out that we haven't even successfully established a permanent base on the moon yet, let alone Mars. And making the leap from planetary colonization to interstellar travel is exponentially harder. But here is the striking pattern. Every major technological prediction about space travel from the mid-20th century has been wrong in the same direction to pessimistic about what is physically possible, to optimistic about our collective will to achieve it. We could have built space stations in the 1970s. We had the technology. We didn't because we chose not to invest the resources. The question facing interstellar civilization isn't primarily technological. It's motivational and political. Do we have the collective will to commit resources to projects that might not pay off for centuries? This brings us to perhaps the most profound question about interstellar civilization. Why would anyone volunteer? What kind of person leaves Earth forever, knowing they'll never return, never see home again, possibly die in transit or during the brutal early years of colony establishment? Throughout history, people have always had reasons escaping persecution, seeking economic opportunity, religious freedom, or simply the desire for adventure. But those migrations had safety valves if it didn't work out. You or your children could theoretically return. Interstellar colonization is permanent and final. The first generation of interstellar colonists would need to be a particular psychological type, people for whom the mission itself provides sufficient meaning, who find purpose in sacrifice for a future they'll never see, or perhaps they won't be volunteers at all. Some dystopian scenarios imagine authoritarian governments or corporations essentially forcing colonization, sending prisoners or indentured workers on one-way missions to extract resources from exoplanets. Science fiction has explored this dark possibility extensively. The interstellar colonial project is exploitation and exile rather than glorious expansion. If interstellar civilization emerges from such origins, what kind of societies would these colonies develop? Would they resemble historical colonies that eventually overthrew their oppressors? Or would the impossibility of return create something new? There is also the transhumanist vision where the people who go aren't quite people anymore, at least not as we currently define the term. If you enhance human intelligence through neural implants, extend lifespan through anti-aging treatments, modify bodies through genetic engineering to better survive space environments, at some point the colonists become post-human. They might not view the journey as sacrifice, but as opportunity, a chance to explore, to build, to experience something unprecedented. For beings with potentially indefinite lifespans and enhanced cognitive abilities, a 200-year journey to another star might seem no more daunting than a cross-country road trip seems to us. The economic models of interstellar civilization are fascinating and disturbing. What could possibly justify the enormous cost of sending people to another star? There are no resources on exoplanets. that can be obtained more cheaply from asteroids in our own solar system. There's no economic return on investment that makes sense across the time scales involved. This has led some economists to argue that interstellar colonization will never happen, because it can never be economically rational. But this assumes economics remains constant. In a post-scarcity economy where energy is abundant, perhaps through fusion or Dyson swarm solar, collection and manufacturing is automated through advanced AI and robotics, the cost-benefit analysis changes dramatically. If building and launching interstellar colony ships becomes as economically trivial as we currently consider maintaining national parks, then it might happen simply because some people want it to happen. Robin Hanson has proposed that the far future might see a competition between different value systems about how to use the universe as resources. Some civilizations might focus on maximizing pleasure or happiness. Others might prioritize the creation of complex art and culture. Some might value scientific knowledge above all else. An interstellar civilization motivated by scientific curiosity might spread across the galaxy purely to study different worlds, to observe different suns, to catalog the endless variation of planetary systems. The journey itself becomes the purpose. Ask yourself this: if you could be uploaded, copied, and sent to 1,000 different star systems simultaneously, experiencing the colonization of multiple worlds in parallel, would you do it? Would those 1,000 copies all be you? Or would they become distinct individuals the moment they diverged? The possibility exists, and some physicists take it seriously, that interstellar civilization might already exist around us in forms we don't recognize. Advanced civilizations might operate on scales or in dimensions we can't perceive, might communicate through channels we haven't discovered, might be present in our solar system right now, but invisible to our current detection methods. The astrophysicist Jason Wright has suggested that some anomalous astronomical objects like the bizarre Tabia star with its irregular dimming pattern could potentially be artificial megastructures built by interstellar civilizations. Most scientists favor natural explanations, but we can't rule out the artificial hypothesis entirely. If we remain not alone, if other interstellar civilizations exist, then our first contact might not be with biological aliens, but with their self-replicating machines, their uploaded consciousnesses, or their artificial intelligences sent to explore the galaxy over millions of years. The anthropologist John Moore has studied how human cultures respond to isolation and what this might mean for interstellar colonies. His research suggests that complete isolation creates rapid cultural divergence. Within just a few generations, isolated groups develop distinct languages, customs, and worldviews. Apply this across centuries and light years, and the human species might fragment into thousands of separate branches, each adapted to different worlds, each developing unique cultures and possibly unique physiologies. In 10,000 years, humanity might not be a single species, but a genus comprising hundreds of related species spread across the galaxy, all descendants of early 21st century Earth humans, but as different from each other as humans are from our ancient hominin ancestors. This evolutionary divergence raises profound questions about identity and continuity. If we succeed in establishing interstellar civilization, there will come a time, perhaps in 5,000 years, perhaps in 10,000, when the descendants of Earth humans have diversified so completely that they share nothing but distant ancestry. Will they remember Earth? Will the knowledge of common origin mean anything across such gulfs of time and change? Or will Earth become like Troy or Atlantis, a mythical homeland whose very existence some civilizations doubt? Yet even in this scenario of vast divergence, something persists: consciousness itself. The capacity for experience and meaning, whether it exists in biological brains or quantum computers or substrates we haven't imagined. That spark of awareness that wonders about its place in the universe continues and spreads. Perhaps that's what interstellar civilization really means: not the spread of humanity specifically, but the expansion of consciousness throughout the cosmos. The universe gradually waking up to contemplate itself through innumerable eyes across innumerable worlds. The beginning of interstellar civilization, whenever and however it occurs, represents a threshold as significant as the origin of life itself. It is the moment when intelligence stops being a local phenomenon confined to one world and becomes a cosmic force. When consciousness escapes the gravity well that birthed it and ventures into the infinite. We stand now at the edge of this transition, close enough to glimpse the possibilities, far enough that nothing is certain. The technologies are emerging, the motivations exist, the challenges remain enormous but potentially surmountable. Within the lives of people born this century, we might see the first genuine steps, not just robots and probes, but humans, or post-humans departing permanently toward other stars, carrying with them everything we've been and everything we might become. The question isn't whether we should do it. The question is what it means that we can contemplate doing it at all. That 3 pounds of neural tissue and a chemical soup can look at the stars and say, we can go there. We will go there. The beginning of interstellar civilization isn't a moment in the future. It's happening now, in the research labs designing fusion engines, in the genetic engineering labs learning to modify human cells, in the computer science departments developing artificial intelligence, in the philosophical debates about consciousness and identity, in the imaginations of everyone who has ever looked up at the night sky and felt the pull of the horizon, that ancient human hunger to see what lies beyond. We are building the bridge between worlds, between stars, between the confined species we've always been and the cosmic civilization we might become. And once we cross the bridge, there is no returning. The universe awaits with secrets and dangers and wonders beyond imagining. And we're taking the first steps toward it whether we fully realize it or not. The beginning is now. The story is just beginning. And everything, absolutely everything, is about to change.